Most people think they own an oven until the electricity stops. Then they realize they only own an appliance. For thousands of years, families cooked without power lines, gas connections, or electronics. Their ovens were built from the ground beneath their feet. And many of them still work today. What you're looking at is nothing more than sand, clay, straw, and water. No concrete, no steel, no expensive materials. And yet, for thousands of years, people baked bread, roasted meat, and cooked entire family meals inside ovens built from little more than dirt. The strange part? Almost nobody builds them anymore. Not because they stopped working, but because we rely on electricity. How could it be any different? We grew up with it, so we don't think about it. And that's a shame, because with materials that cost surprisingly little, you can build an oven that stores heat for hours, reaches temperatures high enough for perfect bread and pizza, and can last for decades. Stay with me. Because today I'm going to show you how this forgotten technology works, why civilizations all over the world relied on it for centuries, and how you can build one yourself using simple materials and basic hand tools. And here's the part that fascinated me most. This isn't one invention from one place. Earthen ovens appeared almost everywhere. Archaeologists have uncovered them in ancient settlements across Europe, the Middle East, North Africa, and the Americas. Medieval illustrations show portable clay ovens mounted on wagons. 18th century records describe them in private homes, military forts, and even communal village bakeries where one oven served dozens of families. Different cultures, different continents, almost the same design. That usually means one thing: people kept building them because they worked. Think about that. Long before electricity, long before gas, people had already solved one of the biggest cooking challenges. How do you capture heat and keep it? The answer wasn't complicated, it was mass. Thick earthen walls absorb enormous amounts of heat from a wood fire. Once the flames die down, those walls slowly release that stored energy back into the food. It's the same reason a stone patio stays warm long after sunset. The material becomes a battery for heat, and the physics haven't changed in thousands of years. Now here's where it gets interesting. If the idea is this simple, why don't we see these ovens everywhere today? Because simple solutions are difficult to sell. An earthen oven is built once. There's no electricity bill, no replacement parts, no complicated electronics, no upgrades every few years. You build it, you protect it from the rain, and it simply keeps working. That's probably one reason this knowledge quietly faded into the background. Fortunately, building one is far easier than most people imagine. The materials couldn't be much simpler. You'll need sand as the main structural material, clay to bind everything together, straw or dry grass to reinforce the outer shell, a few fire bricks for the cooking floor, water, and a tarp to mix everything together. That's it. No specialized equipment, no expensive tools. So let's get practical. Are you ready? First, we'll build the floor of the oven. It consists of a layer of fire bricks. We'll mark the floor plan on it with chalk. The inner diameter to the floor is about 22 inches. That's the interior measurement. The walls will be about 6 inches thick, so we've added markings here too. This allows us to see, roughly, how big the oven will look from the outside. In the next step, we'll build the temporary sand form that determines the shape of the oven. And you'll see why one surprisingly simple ratio decides whether the oven draws perfectly or barely works at all. Before you place a single handful of mud, you first need something that seems completely backward. You build the inside before you build the oven. The easiest way is with damp sand. Pile it onto the fire brick floor and shape it like a large sandcastle. This temporary mound becomes the exact cooking chamber that you'll eventually hollow out. For a family-sized oven, an interior diameter of about 22 inches works well. Large enough for several loaves of bread or a full-size pizza, yet small enough to heat efficiently. But here's the one measurement you can't ignore. The doorway should be about 63% of the height of the dome. That number isn't arbitrary. It's the result of centuries of trial and error. Too tall, invaluable heat escapes. Too short, and the fire struggles to draw enough air. The oven may smoke instead of burning cleanly. The single ratio is what allows fresh air to enter while hot gases circulate naturally through the dome. The physics do the work for you. Once the sand form is finished, cover it with damp newspaper. It seems like a small detail, but it makes removing the sand later dramatically easier by preventing the clay from sticking to the mold. Now it's time to make cob. Cob is simply a mixture of sand and clay. For the first layer, use roughly 2 parts sand to 1 part clay. Sand provides strength, clay acts like glue. Use too much clay, and the oven shrinks as it dries, creating unnecessary cracks. Use too little, and it loses cohesion. The consistency matters more than exact measurements. You're looking for something that feels like firm bread dough, soft enough to shape, stiff enough to hold its form. Roll it into a ball. If it keeps its shape without slumping, it's ready. Press that mixture onto the sand form in an even layer about 3 inches thick. Start at the bottom and work upward. Gravity helps support each new section as you build. Take your time. Consistency is more important than speed. Once the inner shell is complete, let it firm up overnight, not until it's completely dry. Just firm enough that your thumb no longer sinks deeply into it. Before adding the second layer, lightly scratch the surface. Those small grooves give the next layer something to grip. Here's where the construction changes. The outer layer contains chopped straw, hay, or dry grass mixed into the same sand and clay blend. At first glance, that seems strange. Why would you put grass inside an oven? Because the straw isn't there to resist fire. It's there to reinforce the clay while it dries. The fibers tie the material together, making the shell far more resistant to cracking and impact. It's surprisingly similar to the way modern concrete uses steel reinforcement. Apply another layer roughly 3 inches thick, pressing each piece firmly against the first, so the 2 layers become one solid structure. As the material settles, you'll notice something interesting. The lower walls naturally become slightly thicker than the top. That's perfectly normal. Finally, round over the entrance instead of leaving sharp corners. Curved shapes distribute stress much more evenly, making the opening significantly stronger over time. At this point, the oven finally looks complete. But appearances can be deceptive, because the hardest part of the entire project hasn't even started yet. Now comes the part most people underestimate: waiting. Fresh cob contains a surprising amount of moisture. If you light a large fire too soon, the water turns into steam inside the walls. Steam expands, and expanding steam creates cracks. That's why patience is one of the most important building materials, even though you can't see it. Depending on the weather, your oven may need anywhere from 2 to 4 weeks to dry properly. Protect it from rain, but never seal it under plastic. It needs airflow to release moisture naturally. After the first day, you can carefully remove some of the sand through the doorway. This allows the inside to begin drying as well. A few days later, remove the rest of the sand and any loose newspaper. Don't worry if small pieces remain. The first fire will burn them away. And here's the part nobody tells you. Your first fire shouldn't be a cooking fire. It should be a drying fire. Start with a few small sticks. Let the oven warm gently. Repeat this over several days, increasing the fire little by little. You're not heating food. You're finishing the construction. Even if you've done everything correctly, you'll probably notice a few cracks. That's completely normal. Clay shrinks as it dries. Small surface cracks don't weaken the oven. In fact, almost every traditional earthen oven develops them. If a larger crack appears, simply mix a little fresh sand and clay, press it into the gap, and let it dry again. The repair becomes part of the structure itself. But there is one weakness you can't ignore: water. Once dry, cob is incredibly strong, but it isn't waterproof. Leave it exposed to years of rain and nature will slowly dissolve what you've built. That's why traditional ovens almost always stood beneath a simple roof. Not because they needed shelter from heat, but because they needed shelter from weather. And once you understand that, you understand why so many centuries-old ovens are still standing today. Now think about what you've built. Not with electricity, not with steel, not with expensive equipment, just sand, clay, straw, water, and fire. Those ordinary materials become something extraordinary because each one solves a different problem. The sand gives strength, the clay binds everything together, the straw prevents the shell from tearing itself apart as it dries, and the thick walls quietly store energy that would otherwise disappear into the air. It's beautifully simple, which raises one final question. If people understood this technology hundreds, perhaps even thousands of years ago, why has it almost disappeared? The answer probably isn't that it stopped working. It's that our lives changed. Modern kitchens gave us instant convenience. Push a button, turn a dial, dinner is ready. As that convenience grew, the knowledge behind older technologies slowly faded away. Not because it became useless, but because fewer people needed it every day. That's why projects like this matter. They remind us that innovation doesn't always mean inventing something new. Sometimes it means rediscovering something old. Some of the smartest ideas humanity ever developed weren't complicated at all. They simply worked.